Hello, Sahil. Welcome. I've kind of muted everybody's. Hello, Sahil. I muted everybody just so I don't have to worry about a bunch of people shouting. We have more people show up, but you can use the chat functionality if you want to communicate with me. Maybe I'll unmute people if it's just me and you. But if you don't know wherever your Zoom bar is located, there should be a button to do chat, or I guess you can press Alt-H as well. So that's how I'm going to hopefully communicate with people. So I'm using chat. Hello, Jason. All right, now we're getting some people joining. Hello, Jason. Hello, Sahil. Hello, Noah. You guys can use the chat functionality. Sorry, I've got somebody trying to join that I don't know them. Remove people that are not using their real name. Hope everybody's doing all right. Gosh, is it 1? Get started in just a minute here. I'm going to be working from the doc and mainly CodeHS for a little bit. So if you guys want to open that up, you can. Again, I'm just going to have people communicate through the chat. That way I don't have a bunch of people talking and everything. So if you want, you can do that. Hello, if you're just joining us, we're using the chat to communicate. I'll talk to you guys, but if you have questions or anything that you want me to do, you can just you can use the chat functionality and all that stuff. So if you don't know where the chat is, it's wherever your Zoom bar is located. You can just use the chat there. I'm going to be working from mainly CodeHS, so if you want to open that up, you can. You know what? It is, give people about 30 more seconds here. There's somebody that we know. Hello, hello. Weather was beautiful yesterday, and then it little nasty today. Just got back from a bike ride and it was terrible. So hopefully you guys are all, well, enjoying the weather when it's nice. Obviously today's not a great day, but all right. You know what? I think I'm going to go ahead and get started. Again, if you just joined me, I muted everybody and turned off the screens. Just so none of you, maybe I don't want to record the video and then have you, have an issue with your privacy if I record the video and put it online. So I'm recording this, so I disabled your video so that your face won't be on here, which that's all good. And if you have a question, you can just use the chat functionality and I'll try to get around to it as quickly as I can. I'm going to be using the document here. I'm going to go to CodeHS. So I'm going to go ahead. Actually, I already have CodeHS opened up. It looks like many of you were able to get into CodeHS, which is good. I think I had almost everybody in the class in here, which is great. Nice to see that amount of participation. Looks like some of you are farther along than others. That's okay. Like I said in my email and my document, basically we're going to do this unit 1 for this week and next week because I'm supposed to go about a little bit slower than usual. I'm supposed to assign 50% less than I usually would. So where this unit typically should take a week, we'll stretch it out into 2 weeks essentially. So I've got this open. I opened up a little bit of a doc here just to kind of take some notes and what you guys are learning about. The first thing that you learned about hopefully was printing. There's 2 different ways that you can print that you learned about in that first lesson. There's system.out.print and then there's system.out.println. That is an L, it's not a number 1. Essentially, what print does, whatever you put inside the parentheses will print and then stay on the same line, and then system.out.println will print what is between the parentheses and then start a new line. So you folks learned about those 2 functions, system.out.print and system.out.println. You also learned a little bit about what a Java file is. So Java files and main. Essentially, what kind of starts out is you start out with a class. So all of your code, all Java code is contained in a class. You probably learned that class must have the same name as the file. So for example, if you have a file called my first program.java, then the first line of your program would be public class my first program. And then there's these curly braces that kind of contain all of your code. So all Java code is contained in a class. You can think of it like a Word document, except for your Java code. And the name of the class always has to match exactly the name of your file. And then you probably also learned about the main method. This is run or executed is another way you might put it when you hit the run button. And so eventually we'll get to a point in programming where we're writing many different functions, many different what you might call methods that all have their own job. Main is kind of the one that breathes life into your program. And the header for main always looks like this: public static void main string square brackets args. I can only type it quickly because I've had to type it probably, I don't know how many thousands of times in my life, but all programs usually have a class and then public static void main. And for right now, we'll just kind of start there where you write your class on the first line and then main under that, and then you'll do some printing. Now that I think about it, it probably makes more sense to have this before printing here. Let me just do that, reorganize my notes a little bit. There we go. So starting out, Java files, all of them go into a .java file that has to have the same name as your class. So if you want to name it my first program, then it'll get saved in my first program.java. And then you have a main method, and that's essentially what happens when you hit the run button, and its header always looks like public static void main string args. Eventually we'll talk about what all this stuff is, but just know for right now, when you're writing your program, everything goes inside of that header, that public static void main. And then in the first section, I believe you learn about printing, and they take you through a couple of these exercises and activities. I'm going to leave these up here for a second. In the chat, if there's one of these you would like me to do, one of these you'd like me to go over, if you know 124, 125, 126, if there's one of these that you got caught up on, I can go ahead and work through it. I'll give you guys a second here if there's one of these that you want me to work through. If you don't know the chat functionality, it should be somewhere wherever your Zoom bar is located. I think you can put it at the top or the bottom of your screen, depending on how you want to run things on your screen there. But are there any of these that you guys want me to work through? You guys know where the chat button is? Can anybody hear me? Oh, thank you. Thank you. Okay, 124. Is 124 an example or an exercise? Let's see. This is an example. Well, I can go ahead and start here and see where it takes us. So this is kind of just an example showing you, first of all, what the CodeHS window looks like. There's a lot going on here. Maybe I can talk about that in this example really quick, and then we can kind of run through this example. On the left, it shows you any files. This is kind of what I was talking about before. This is a file called printing.java. So you'll notice that it's located in a class called printing. This matches this. So right now we're working in this printing.java. Curly braces kind of enclose your code. So a left brace is like the beginning and a right brace is the start. Depending on how you like to go style-wise, you might leave this brace right here. You might put it up on the other line. Really stylistically, that's kind of up to you there. And so you'll see it here in this example, they've got a couple different prints. Any of these print LNs will print whatever inside the parentheses followed by a new line. So in this case, it'll print hello world, then it'll start a new line, then it'll print another line and start a new line. So it doesn't do the new line, that's what the LN is for, until after it prints whatever's in the parentheses there. If you're wondering, what are these quotation marks? Not sure how much CodeHS talks about it, but the quotation marks go around what we call a string, which is a special value that is essentially, it's exactly how you want it to show up, a string of characters. So if I want hello world to show up on the screen, I put inside a quotes there, and then a new line and another line. Now these down here are prints. Since these are just print statements, it's going to print and then stay on the exact same line. So I'll say print will add 2, it'll stay on the same line. Notice there's a space here before the quote. So it'll put a space and then the next thing will print out the same line. Lastly, in the CodeHS window, you see this run code option. And when I go ahead and click that, it actually runs my main method. So it goes over to my class, it finds where the main method's located, and it starts from the top here, line 5. It prints out hello world, new line, another line, new line. And then we see that these last two print statements only show one line together because it was a print instead of a print ln. So the nice thing about this example is I can go ahead and add to it. I can go ahead and do something, well, if I just want to start a new line just blank, I could do something like that. And now just add a new blank line at the end. And I could say something like, how is everybody doing today? Something like that. And now if I go ahead and save my code, oh, I meant to hit, go back. Oh, so error, so bad, sorry. And then I go ahead and click run code. Now I should see my new message, how is everybody doing today? And it's on a new line. Why? Because I put this blank println, and then I put how is everybody doing today inside quotation marks. If you forget the quotation marks, I think you get some issues. I'm guessing my code won't run. I'll probably get an error message popping up. And it's nice because actually, if you can see the error message there, it kind of highlights what the error is. And tells me how to fix it. You forgot a semicolon, blah, blah, blah. So I would go ahead and, well, I got to put the quotation marks back in. Sometimes the error tells you what line it's on, but not exactly what the error is. So I'm going to try that, and maybe I can run my code again and see if my error goes away. Okay, so then my error goes away. So that's println. Now that one was just kind of an activity, an example there. Are there any of these other exercises from 1.1 that people wanted me to, oh, that's one, well, 1.2, excuse me, that people want me to go through? ASCII art, fixing a paragraph, heating up, personal timeline. Okay, so we're feeling good on print. Is that a true story? Okay, I'm going to say that that's a true story, that we're good here on printing. I'm going to look, I'm probably going to get through 1.3, 1.4, maybe 1.5. We'll see where we're at. 1.3, you start looking at variables and their types. So if I switch back to my notes here, and I would recommend, you know, when you guys are doing this, I would highly recommend either if you have a notebook or just a Google Doc open to take notes, that's great. Otherwise, you have to keep clicking back and forth to get to the video, take notes, get to the video, take notes, get back and forth and all that stuff, and then go back to the exercise. If you just take notes on either a Google Doc, and you can keep it running like that, or if you have a notebook that you can write stuff down in, that's great as well. So the next thing you learn about here kind of in 1.3 is about variables. So variables, a couple things here that we want to talk about when we're talking about variables. First of all, they are a storage location with a name that can only hold a particular type of data. So when you make a variable, you specify what that variable is going to be called. Basically, anytime you want to use a value more than once, or if it's a value that's going to change throughout the course of your program, you should definitely use a variable. For example, if you're going to use a mathematical constant, if you're going to make a program that's going to calculate the price of candy, if you have number of pounds and price per pound and stuff like that, you want to put those into a variable. Variables are a storage location. You can think of it like a school locker that has your number on it, and you can only store certain stuff inside of that variable. So as an example, you might do something like int, no, let's say lucky number equals 7, something like that. And that's a line that goes ahead and creates a variable, and there's a couple things that I want to talk about on this line here. There's two parts of creating a variable. There's declaration, and declaration is essentially giving the type and name to a variable. In this case, I've said int, which means it's only going to hold integers. So negatives like -1, -2, -3, 0, 1, 2, 3. Actually, the range of integers goes like -2,147,000,000 something to +2,147,000,000 something. So this part right here on the left side, we would call that, let me actually highlight it here. That would be declaration. Oh, that's easy to see. I'm so glad I chose that color. Let's try this again here. Oh boy, Gaff City, hold on. Let's try this. Nice shade of red there. There we go. Okay, and highlight. There we go. Nice little fleshy, okay, blushy red there. So that's the declaration. That's where you give the variable a type and a name, essentially what you're going to call it for the rest of the program. And then there's also initialization. And initialization is basically giving the variable a starting value, giving variable a starting value. And so the part over here where I have this equals 7, obviously that's my my initialization. I'm essentially telling it what value to go ahead and start at there. So somewhere in the computer's memory, there's a box that we're going to refer to as lucky number that contains the value 7. You can technically split those operations up as well. I could do int lucky number on one line where I just go ahead and do the declaration. And then on another line, I could do the initialization. So those could be split up as well. Why would you want to split them up? You know, maybe you start your program and you don't know the value of a variable at the beginning, but you know you're going to go ahead and initialize it later on in your program. That's an example of when you might want to go ahead and not initialize a variable immediately, but just declare it, essentially give yourself that space. Now, you can name your variables whatever you want to, but there's some rules. Names must start with a lowercase letter. That is a must, and well, let me go back here for a second. Names, I'm going to say must start with a letter. I'm going to say should start with a lowercase letter. If you were to go ahead and name your variable lucky number with all capital letters, that would technically be okay. It would technically be legal, but other programmers will look at it and laugh at you and go, this person doesn't know what they're doing, and you don't want to get laughed at by your programming friends. There's too much negativity in the world today. So just go ahead and be a little bit more positive. Start with a lowercase letter. And then also, you want to use camel casing to name your variables. So for example, if you have a variable that has a bunch of words in it, but you can't use spaces or anything like that, you could do something like int number of days in a week. And that's an example of camel casing where I start with the lowercase letter and then every subsequent word I capitalize it. So that's what's called camel casing, and that's a good way to name your variables. You can use numbers as well. The thing we want to avoid when we're naming our variables, avoid alphabet soup variable. Essentially what I'm saying when I say avoid alphabet soup variable names, don't name your variables A, B, C, D, E, F, G, H. I know in that first week, which was the only week when I saw you guys, we talked about you want to make your code readable, not just for you, but for everybody else. If you use alphabet soup variable names, nobody else is going to know what A, B, C, D, E, F, G, H, I, J, K, stands for. So you want to use variable names that are verbose and at least descriptive. They don't have to be 300 characters long, but you want to be descriptive with what your variable is doing. As for types of variables, int, these are your integers. So whole, usually we say like whole numbers or something like that, your negatives, zeros, and positives. There's a double, which are numbers that have a decimal point, or if you want to say a mantissa or a remainder, whatever, anything like 3.14159, that's a double value right there. Something like that. So ints are your integers, doubles. So I could do something like double pi equals 3.14159. And that would be legal, but if I tried to make that an int instead of a double, I'd have issues. My code would not compile. I'd be very sad. So there's that. And then I'm not sure how far, do they talk about strings? I don't know if anybody's gotten through 1.3. I'm just going to put strings on my notes as well. There are strings, and string starts with a capital S. We'll talk about why probably maybe in the next unit, but strings are to store a sequence of characters in quotation marks. So I could do something like string greeting equals hello, everybody, something like that there. And notice that there's quotation marks around that type where there's not quotation marks around doubles or ints or strings or anything like that. So a lot of information about variables. And then lastly, I guess I wanted to say variables can change. Surprise, surprise, they're called variables. They vary, they can change. So if on, you decide later on that your lucky number is not 7, you can go ahead and change your lucky number to 8. There you go. And so they can change and all that stuff. So I think that's a decent look at variables there. Does anybody have a question in chat? Okay, maybe what we can do, I've got up the exercises. I'm not going to do a quiz, obviously. Ooh, they talk about final. Are there any of these exercises, 138 or 139, that you folks would like me to take a quick look-see at? 139, let's check it out here. Okay, football rankings, interesting. It says, the football season is here and the rankings are out. Unfortunately, the weekend's games have shuffled all the teams. Sorry, I've got to move my face out of the way here. Let me just minimize. Your task is to switch the teams around and get them in the new order. You should do this by switching variable values, not just retyping the names. Remember, a variable can only hold one value, so you will need to use a temp variable to make the switch. Ooh, interesting. For example, if we wanted to switch team 1 and team 2, we would swap values like this. So if team 1 is A, that's a string value, and team 2 is OSU, then we can't just do team 1 equals team 2 and team 2 equals team 1. Otherwise, it'll kind of copy it over. So what we do is we have this temp variable that'll temporarily store what team 2 is, hold on to it. Then in the next line, we go ahead and write over what team 2 is and replace it with team 1. And then lastly, we take that value we copied on the first line right here and store that temporary value back into team 1 to kind of switch them. And you can follow the trace right here in the comments over on the side. Ooh, Michigan below Wisconsin. That's interesting. Okay. Your task is to switch the teams around in the new order. Okay. New order, sample, output. Wow, Penn State number 2. Okay. So I think I get what we're doing on this one. Let's go. And so this is the CodeHS window again. We see that the team ranks.java is the name of the file we're working in. That's why it says public class team ranks up at the top. If you ever forget what you're doing, like I kind of just did, you can click on assignment over here and it will show you what you're supposed to do. The weekend's games have shuffled the teams around. So I'm supposed to do this new order. Okay. So I'm looking here. Alabama does not need to move. It looks like Alabama stays in the same spot. Does Ohio State swap spots with anybody? Oh boy. Okay. So instead of just doing team 1 equals Alabama and so on and so forth, I think what they want us to do is do some swapping with these different teams here. I'm trying to see if 2 teams just switched spots completely. Alabama stays in the same spot. Penn State doesn't swap though. Penn State moves from 6 to 2. And the person that was in 2, Ohio State, drops all the way down to 10. Must have been a crushing defeat for Ohio State. Well, I'm going to try to do this the way they want me to. It's just a little bit tricky for me to see both rankings at the same time, so I'm just going to make it a little bit smaller here. Team 1 does not change. Team 2, I'm going to do something like this. String temp equals. I'm going to make do a lot of swapping here. All right, Penn State was originally 6. So I'm going to do team 6. And then I'm going to say no, wait. Hold on. That's not what. They're not doing a direct swap, though. If you don't understand what I'm saying, I mean, I could technically just do team 2 equals Penn State. and so on and so forth. And that would be fine, but it's not really doing a swap in that case. Gosh, how am I supposed to switching variables, not just retyping names? Well, how the heck, how many swaps do I have to do here? Alabama stays where it's at. Ohio State moves from 2 to 10. Okay, maybe I'll just do that one at a time. String temp equals team 2. But then they switch, and how am I going to keep track of? Sorry, if you am I missing something in this one? Oh, into the original, and it worked. Okay. I mean, I know I could just go ahead and cheese it, and I could do something like team 2 equals Penn State, but then that's not what they want me to do. They want me to do a bunch of swaps, but the issue is there's not straight up swaps happening. Am I missing something? You guys understand? If you don't know what I'm saying in chat, let me know, but I think I need like a sheet of paper to write down all the swaps I have to do. Let me just do one swap and maybe we'll go from there. So let's say I want Ohio State to go down to 10 and I want the team currently at 10 to go up to 2. Maybe I'll switch Ohio State and Michigan, for example. So I'll do something like this. String temp equals team 2. And then I can say team 2 equals team 10. And then I can say team 10 equals temp. And something, if I do something like that, I'll see that, I should see that Ohio State and Michigan swap spots. Let's see if that's a true story. Yeah. So it's telling me, oh, your code didn't work. If you ever find that your code doesn't work, you can click this test case button and do check code, and it'll tell you exactly what yours was and what the expected output is. And so now you can see in mine, Michigan moved up to 2, and Ohio State bumped down to 10, and it tells me, oh, that's not the correct order. And I would obviously have to do a couple more swaps. I would probably get out a sheet of paper to keep track of all the swaps there, but do you guys kind of understand? Can I get a Y in the chat if you understand what you're supposed to be doing, or a question if you have one there? Y in chat if you know what you're supposed to be doing, or a question if you don't. All right, Mr. Foster's just talking. That's okay. That's okay. I'm gonna. So if you did it differently, if you just went ahead and typed in, you know, team 3 equals blah blah blah, that's okay. But I think what they want you to understand is the swapping that's going on. I guess if you do that and understand the swapping, you're probably okay doing it that way. But the main idea is that you understand how to do that swapping operation. If you get it to work without the swap, I assume that's okay. One more thing about CodeHS: when you get something working, you want to make sure you click this submit and continue button, and then click OK, and it'll show you green check marks if your code passed. If it didn't pass, it'll say something else. But the only way that I see it in my gradebook is if you hit submit and continue. If you don't hit submit and continue, then I don't really see it. And so it makes it hard for me to give credit. And I'm sure there's going to be more announcements from the school going forward, but essentially the idea is right now we're going to be able to provide credit or no credit. And all I'm looking for is, you know, a good level of participation at this point from you folks. So as long as you're participating, which many of you are, I've been following the results on the CodeHS website. That's great. Some of you have not been participating, but maybe it's just you didn't know to hit the submit and continue button up at the top. Maybe your code is already saved in there and you just forgot to hit submit and continue. That's fine. CodeHS stores all that stuff in the cloud, so it's all good, and you're totally okay there. Instead of me spending a bunch of time and just getting out a sheet of paper and tracing and all that stuff where everything's flip-flopping, I am going to move on here, if that's okay with you folks. So the next part is talking about arithmetic expressions. So I'm going to make just a little new header in here. Arithmetic expressions. So there are 5 basic operators in Java for doing arithmetic. You've got your plus sign, which is obviously addition. You've got your subtract. Maybe I should not use a subtraction sign here. Plus sign, which is addition. You've got your minus sign, which is subtraction. Don't call it minusing. That's not a real verb. Come on, you jokers. Let's do, you got a forward slash. It's the one that shares the key with the question mark. That's your division. You got the asterisk, shift 8. That's how you do your multiplication. And then on the next line, you got one more guy, this percentage sign, which is called modulus, or you might say modulo, or usually for short, we just say mod. And essentially that is giving you the remainder when you do division. So those are your 5 basic arithmetic expressions that you can do in Java. Those can be done with variables. So you can add 2 variables together. You can add values together. I'm just going to put that in here. Can be done with variables, values, or a combination of the 2. So for example, I could do, let's say, int days in a year equals days in a week times weeks in a year. 2 variables, that's fine. I could also do, maybe I don't have a variable for weeks in a year. I could do something like days in a year equals days in a week times 52, and that would be fine. And then lastly, I could just do int days in a year equals, 7 times 52. And those are all fine, and they're going to store basically the same result into days in a year. But you can do variable times variable, or plus, or, addition, subtraction, mod, division, whatever. You can do variable and value, or you can do value and value. So those are the 5 quick arithmetic expressions. Not sure how deep they get into, CodeHS gets into modulus, but it gives you the remainder. What I mean by that is if you do something like, let's say 25 mod 6, for example. 6 goes into 25 4 times evenly, which leaves 24, which means there's a remainder of 1. So this would yield 1 in that case. If you do something like 9 mod 5, well, I've got an idea. 9 mod 5. 5 goes into 9 1 time, so the remainder here is 4. Here's another one, maybe 10 mod 3. How about in chat? In chat, what's the result there? 10 mod 3. Anybody know? Got to think about how many times does 3 go into 10 evenly? And then what's left over? Any ideas in chat? Nobody wants to stick their neck out when we got such a small group. I understand that. So 3 goes into 10 3 times, which leaves a remainder of 1. So that's kind of how mod works there. It gives you the remainder. And one quick note, if I do 5 mod 9, well, how many times does 9 go into 5? 0. So there's a remainder in that case of 5, actually, because 9 goes into 5 no times, which leaves that 5 left over. So those are the 5 arithmetic expressions. One quick note, when dividing 2 integers, you will get back an integer. Sometimes we call this integer division truncation. And essentially what that means is if you do something like, let's do something simple, 30, no, that's too good of a number. How about 26 divided by 5? Since 26 and 5 are both integers, I'm going to get back an integer. An int divided by an int gives you an int. A double times a double gives you a double. Essentially, the variables or values used in the operation, you get that value back. So And when you're dealing with mixed data types, like if you have a double and an int, you'll get back the more precise one. So for example, a double times an integer will give you back a double. So if I do something like 3.2 times 2, well, 3.2 is obviously double, 2 is an int. The more precise of the two is double, so I will get back a double. Essentially, you always get the result in the form of the more precise variable type. So I'm talking about types here. I'm not like talking about typing on the keyboard. What I'm talking about is the types of values that you might have either for a value or a variable, like int, double, string, etc. So, and obviously you're not going to be doing subtractions with strings and stuff like that. But now we might be getting into territory that people have not gotten to here yet. Maybe I can look at this. How about this weight of a pyramid one? It says, write a program that estimates how much Khufu, who's Khufu? Khufu's pyramid in Giza weighs. Your program should assume that every block weighs 2.5 tons. For reference, Khufu's pyramid in Giza used around 2,500,000 blocks. You should use two variables, num blocks and block weight, to calculate the weight. Here's an example output. The pyramid weighs, okay, that's a lot. Okay, so I'm supposed to estimate. Your program should assume that every block should use two variables. Okay, num blocks. So I'm going to do int num blocks equals, I don't know, maybe let's just say Khufu used 5 blocks just for sake of argument. And maybe I'll do double block weight equals, it says 2.5 tons per block essentially. Now my thought is, if I take the number of blocks and I multiply it by the block weight, I'll get the total weight. So maybe I'll make one more variable. I think a good name for this variable might be total weight. I'm going to calculate that by doing num blocks times block weight. Now, a couple things about this line here. Num blocks is an int, but block weight is a double. When I do an int times a double, double is the more precise of the two types, so I will get back a double. That's why I've stored the result as a double. And now to do my output, maybe I'll split it into 2 lines, and then I can show you a trick to make it 1 line. In 2 lines, I would do the pyramid weighs, and then I'm just doing a print because I want it to stay on the same line. I need a space here. Thank you for those of you that noticed that. Then I would print out the variable's value. Now, if I'm just referring to a variable, I want to print out that variable instead of a string of characters, I don't put quotation marks around it. So here I would just say total weight. And then maybe I do one more line here that says something like system.out, because I've got this last part at the end. I've got the pyramid weighs, and then I've got the total weight, and then I'm supposed to put tons on the end. And I'm going to put space tons. If you're wondering why that space is there, there was a space before it printed out total weight. Now I want a space before it prints out tons. Let's see here. So you could either do check code in the test cases. Maybe I'll do that first. Check code. Checking the weight of the pyramid. You should print the weight using a sentence. Good. $12.5. Checking the weight of the pyramid is correct. Oh, am I supposed to use Khufu's values? Am I supposed to use Khufu's values? Is that what they're trying to tell me? 2,500,000? Okay, Khufu, fine. So this was not what needs to be changed. This needs to be changed. 2,500,000. Is that seriously what I was supposed to do? Use Khufu? Okay, I was supposed to use Khufu. Excuse me, everybody. I did not understand that I was calculating the known value of Khufu's pyramid's weight. Well, there it is. The pyramid weighs blank tons. And if I were to go ahead and change this, it would recalculate it to the other value, whatever I change the number of blocks to. Now, some choices, I know they talk about final, making variables final at some point. If you make a variable final, that just means it's a value that's not going to change. For this problem, I could do something like that. If you do use a final variable or what's called a constant, you do all capital letters with underscores in between them, and that's kind of another option. And then last thing with CodeHS, you just want to make sure you hit the submit and continue button when you're done with a certain problem there. I'll go back to it. So how does that one make sense? Does anybody have questions on this one here, or are we good? Maybe I shouldn't have made this a constant. That might have confused people. It doesn't say to do it. I'll just go back to what I had before. I just made it a constant because it seems like the block weight is the same the whole time, but I don't need to make it a constant. Okay. Seems like we're doing all right. I don't know, I got about 15 minutes left here. Are there any more of these exercises in one, like this add fractions one, freely falling bodies? Do you guys want me to do that? Do you guys want me to move on to 1.5? I'm here for you. All 5 of you, I'm ready to move on to compound assignment. 1.4, is this like, you know, in The Sixth Sense? Oh, I don't want to spoil it, but like, there's a ghost, the whole movie that you don't know is a ghost. He doesn't know he's a ghost until he's just talking to people. Nobody all right, I'm going to move on to the last part here, compound assignment operators. Here's the deal with compound assignment operators. I'll just make one more little header down here. Compound assignment operators. Sometimes you want to do something that is called self-assignment. Essentially what self-assignment is you're using the variable's previous value to calculate its new value. So for example, let's say you have an age. Let's say you're 16 years old, but then you hit your birthday. How do you make your age one more than what your age previously was? Well, you can write a line of code that looks like this. This line of code I just typed says make the new value of age equal to the old value of age plus 1. So in this case, if before I was 16, now I'll be 17. And that's called I'm much older, but that's called self-assignment. It's where you use essentially using a variable's old value to calculate its new value. So that's essentially what you're doing with self-assignment there. And it looks a little confusing because if you did this in algebra class, you try to balance the equation, you'd subtract age from both sides. You end up with 0 equals 1, and then you know that can't be true, and all the mathematical laws of the universe fall onto each other, and then who knows? But in Java, this basically means the variable's new value is equal to its old value plus 1. The right side of the equal sign happens first, and then it gets stored back into age here. Now, there's the self-assignment is something that happens a ton when you're doing programming. Here's another example. Let's say that you are at the grocery store and your total is 0.0. Well, then you go ahead and you buy a bag of potatoes. Well, the total now is going to be equal to the total, plus the bag of potatoes cost. Potatoes cost. E on the end. Let's make a bag of carrots. It's easy. Okay. You guys ever know Dan Quayle, former Vice president couldn't spell potato. True story. And so total equals total plus bag of carrots cost, and then so on and so forth. You can add on to it. Maybe there's a discount. Maybe you got a coupon for 20% off your total bill. So you could do something like that. Total equals total times 0.8. That gives you 20% off because it's saying the total is 4/5 of what it previously was. Then maybe you want to add tax to that. You could say total equals total times 1.06 because that's the sales tax in Michigan. Who knows? You can do all different kinds of stuff with self-assignment, but it just says the new value is the old value plus something, or the new value is the old value times something. So self-assignment is something that you do all the time. And since it's something you do all the time, there's these special symbols that are built into the Java programming language. If you just want to go up by 1 or down by 1, we call that incrementing or decrementing. Go up by 1 or down by 1. So you can easily increment the line that I had before that was age equals age plus 1. I could just do, here's my example of incrementing, age plus plus. That line of code is the same as age equals age plus 1. I can decrement really easily. Let's say that, oh boy. You guys ever hear that song about the monkeys jumping on the bed? One fell over and bumped his head. So maybe you could do number of monkeys minus minus. And those are two subtraction signs up there. What that means is num of monkeys equals num of monkeys, monkeys minus 1. So those are just fancy ways to either make a variable go up by 1 or make a variable go down by 1. Plus plus makes it go up by 1, minus minus makes it go down by 1. There are also things called compound operators, and those compound operators allow you to do more than just go up by 1 or down by 1. Let's say you wanted to go up by more than 1. Let's say you want to count by 5s or something like that. You could do number plus equals 5. Now that looks pretty complicated. What does number plus equals 5 mean? That line means the same thing as number equals number plus 5. It's just a fancy way to write your self-assignment. But we do it so much in programming, we want to use these ways to, it's like shorthand to make something do it faster. It's like a contraction. Instead of writing cannot, you do can apostrophe T. Instead of writing number equals number plus 5, you write number plus equals 5. They're equivalent expressions, just the one on the left is a little bit faster. And if your programming friends see the one on the left, they're going to think you know what you're doing. If they see the one on the right, they might laugh at you. You can do the same thing with subtraction. Here's no shocker to you guys. If you want something to go down by a value, you do minus equals. That is the same as, I don't know why it's letting me use that symbol sometimes and not others. If I do number minus equals 10, that's equivalent to number equals number minus 10. If I want to do the same thing with division, that's fine. If I want to cut something in half, if I want to take my number variable and cut it in half, I do divide equals 2. That is the same thing as number equals number divided by 2. And then I'm sure you guys can see where this is going. The same thing is true for multiplication. If I want to make something bigger by a factor of 10, if I want to multiply it by 10, I can do that, which is the same as number equals number times 10. It just says the new value of number is the old value times 10, but it's a fancy way to write it. So it's these compound operators are basically fancy ways to write self-assignment. You can do it with mod as well, but I'm not going to get into that right now. But those are just fancy ways to do self-assignment there. So plus equals, minus equals, divide equals, times equals, etc., etc. It's just a way to say the new value is the old value times this, or plus this, or minus this, etc., etc. So maybe I'll just do one of these quick activities here. How about work shift? Let's look at this one. says a doctor works 20 hours, 42 minutes, and 16 seconds in one shift in a hospital. Okay, I love our healthcare workers, obviously, and they're heroes during this time and always. But isn't that insane that they work 20 hours in one shift? Can you imagine if they're doing surgery on you at the end of their shift? What, have you ever stayed up for 20 hours in a row and then try to do something? You're barely functional, let alone trying to go do surgery on somebody or deliver a baby, or you got somebody bleeding out on you? That's wild. I can barely teach like 4 hours in a row, let alone doing surgeries for 20. Okay, I'm talking too much here. Let's keep going. Convert the total shift time into seconds and display that information. Okay. Okay, so my assignment. So I'm going to put the doctor works 20 hours, 42 minutes, and 16 seconds. That's just information that was right from these values here. Convert the total shift time into seconds and display that information. You must use at least one compound operator. Okie dokie. So I'm going to make a variable called total seconds here. I'm going to start it at 0. And then I'm going to do, let's add on, well, I can add on the seconds using the compound operator. There we go. And then let's see, the number of minutes. If I do total seconds plus equals minutes times 60 seconds in a minute, yes. So I'm adding the number of seconds plus the minutes converted into seconds. And then if I do total seconds plus equals hours times, let's see, there's 60 minutes in an hour times 60 seconds in a minute. That should give me that value. And then maybe I'll print out, am I just supposed to print out how many total seconds? Something like that there. Let's see. How are we looking? Printed the number 74,536 seconds. So did I use the compound operators? Heck yeah. So how does this all work? I took the number of hours, I took the number of minutes, I took the number of seconds, and then I made a variable to keep track of all of the seconds all together. And essentially I first added the number of seconds to the total. Then I took the minutes and converted it into seconds and added it to the total. And then I took the number of hours and converted that into minutes and then converted that into seconds and added that to the total using the compound operator and then printed it out. If you ever want to make your output look really nice, you could always add on something like this. Total, something like that. But I don't think that's what they want from me right now. I think they want me to do something else there. But anyways, so I got total 74,536. No worries if you're just joining us. I have been recording this whole thing. So if you missed any of it, I've been recording it. I am sorry that some of the meetings this week took place at the same time. Same thing happened with my meeting this morning with my AP kids. They just didn't have a schedule yet. So I am recording this one. I'll post it on YouTube. I'm just double checking that everybody's privacy is safe before I go ahead and put something on YouTube, obviously. But it's just me talking, and then it doesn't record your chats at all. So I think we'll be okay there. But anyways, that's compound operators as well. And so, I think I covered all the way through. Let me just go back for a second here and see where we were at. I think I covered most of the information from 1.1 to 1.5. You are going to have time to do all of this over the next week as well. If you're just joining me right now, I said at the beginning, essentially this unit would usually take a week. We're stretching it out over 2 weeks because I've been instructed to go at 50% my usual speed. So I covered some information from 1.1 to 1.5. I did take some notes. Would it be helpful to share my set of notes on the classroom? If that would be helpful, can you give me a Y in chat? If you don't care, you don't have to. Okay, looks like that would be helpful. So, just a few things here before we wrap it up today. I'm sorry that I originally had 2 hours for this, but I they told us we had like a meeting yesterday that we're only supposed to do an hour at any given time. So wasn't my decision, but it's a decision. And so I'll come up with a schedule. They kind of gave us a preemptive schedule to use next week. I'll set one of these up again where I go over the units that I didn't cover, which was 1.6, 1.7. I'll go over those a little bit. I'll put this on YouTube. I'll put this on YouTube, and I'll put my notes into a classroom announcement. I'll put both of them up. Just a few quick recommendations before we wrap it up, everybody. When you're doing this stuff, I would try to have like no distractions. I did my whole master's online, and if you have your phone out or the TV on or whatever, it can be super duper distracting and slow you down. And then you realize you've been working on something for 3 hours where it really should not have taken you that long. So first of all, just try to get rid of any distractions. Just be present, whether it's a meeting with me or you're working on this stuff on your own. And find a place where you can relax, maybe put on some music without words. The research says music without words is easier to focus to than music with words. And then, like I said before, have out either a notebook or, like I just did, a Google Doc here, something where you can take notes on the videos, on the examples and stuff like that. And then you don't have to flip back and forth. You hit the back button in your window, go look at the video, go back forward, do the exercise, hit the back button again, go to the video. Here you can I've got my notes and I can just switch tabs really easily. So that's my other recommendation for you going forward. I do have some options on the document for some extra programming stuff, maybe for those of you that are experienced or you just want to try something else out. I put up the link to Code Combat. Unfortunately, they don't have a Java track, but they have a JavaScript track, which is similar to Java in many ways. And it's like you're playing a game using an RPG. Also, using code, I should say. And then also I put up the link to the coding train if you want to do more stuff in processing. Lastly, make sure when you finish an activity, you hit the submit and continue button. That's the only way it shows up for me and gives you credit, is if you hit submit and continue. So make sure you do that. If you have any questions, I will have time to answer emails, obviously. And then I will have a couple of you signed up for some times. I'll have that link up again to that doodle poll. I just want to show you what it looks like for those of you that didn't sign up for a one-on-one meeting, which is fine. The way that this doodle poll kind of works is it's my calendar time that I've made available just to meet with you folks. And it looks like this, and you can essentially click on one of those times and it'll book off that time for just you and me. And then before your meeting, I'll send you a link to like a Google Hangout or I think it's called Google Meet now. And then we can meet and talk, something like that. So I'll be putting up the list and links and all that stuff for next week, probably on Sunday. Thank you all for joining me. I'm sorry that we had to cut it a little bit short today and only do an hour instead of the planned on 2, but it was so nice of you guys to join me. I miss you folks dearly. I want you to know that. I would much rather be in the classroom with you folks than doing this weird virtual business stuff. So hopefully I'll see you again soon, whether it's through Zoom or somewhere else. Stay safe, stay healthy, and we'll talk again soon. Bye, everybody. Thank you.
See you, Mr. Foster.
See you, Sam.